right here, right before example 2, the bottom of page 17, we have our factor theorem, and our factor theorem is saying what we just did here, right? What we did here is we had a polynomial. First we plugged in 2, we found out the remainder was 12, so that means that x minus 2 is not a factor. But when we plugged in 1 and we got a remainder of 0, that tells us that x minus 1 is a factor. And so when we do our synthetic division with 1 and we get our remainder of 0, we can now write our division statement, and our division statement is starting to factor.
Px, wouldn't that be x squared plus x minus 6?
This px right here would be the x cubed plus 5x minus 6, because we labeled p of x at the beginning to say what it was. And we started to factor that. So example 2 says, if you had, this is not example 2, this is example 2. If you had this new polynomial, and I'm going to call this, and right above it I'm going to say let p of x equal x cubed minus 6x squared plus 5x plus 12. If you want to see if something is a factor, then the remainder has to be 0. And to find the remainder, you have a choice. You can either use synthetic division, or if you really like writing out things the long way, you can use long division. It's just longer. Or you can use the remainder theorem. So in A, if I'm dividing by x plus 1, I'm going to use the remainder theorem. That means I'll plug in the opposite sign, negative 1. And I like using the remainder theorem when the number is 1, because the mental math is really easy. When the numbers get bigger, like the 3, the 4, and the 4, I'm probably going to use synthetic division, because I don't want to do 4 cubed and write 64 and do all those big numbers mental math-wise. So, but for negative 1 cubed, that's going to be negative 1. Negative 1 squared is positive 1 times a negative 6. That's negative 6. 5 times negative 1, negative 5 plus 12. And when we add all these together, we get 0. What does that mean? So x plus 1 is a factor. And we found one factor already. For B, I'm going to use synthetic division. In synthetic division here, if I'm dividing by x minus 3, I'd put a positive 3 outside. Everything's in order. Do I have to put a 0 in anything? Nope, we've got something. So I have 1 minus 6, 5, 12. Bring down the 1, multiply, add, multiply, add, multiply, add. We get a remainder of 0 again. So we now know that x minus 3 is also a factor. This is exciting. It's probably only exciting for me because I know where this is going, and you're like, okay, we found another factor. Whoop-de-doo. Okay, but it is, trust me, it's going to be exciting in the end, especially if you enjoy factoring. Okay, if you don't enjoy factoring, just pretend to be excited. That's the, yay, okay, thanks. That was really obvious that you were pretending. Okay, for C. So now we're going to divide by x minus 4. So again, that's a bigger number. I'll probably choose synthetic division. 1, negative 6, 5, 12. Bring down the 1. 4, add. Negative 8. Add. Negative 12. We found another factor. Are these all going to be factors? That's what we hope so, because I seem to get so excited every time we find one. So x minus 4 is a factor. Seems to be a pattern here. In D, we're dividing by x plus 4, so we put a minus 4 out front. 1, negative 6, 5, 12. Bring down the 1, negative 4, negative 10, 40, 45. Ooh, it's not getting nice numbers here. Negative 180, negative 168. That is not a 0. X plus 4 is not a factor. But what does this mean? Why am I so excited about these things? Well, we found 3 factors. We started with x cubed minus 6x squared plus 5x plus 12. By saying that we found 3 factors, we know that this is equal to, well, one of the factors was x plus 1. Our second factor was x minus 3. Our third factor was x minus 4. And so technically, we have factored that completely.
How do we know we factored it?
Good question. How do we know that it's factored completely? Well, with an x cubed, you can have at most 3 factors. And the reason for that is the same sort of rule applies that if I multiply all my first ones together, I get x cubed. X times x times x makes x cubed. So at this point, we know that we factored this completely. So when we were trying that 4th one, I already knew there's no way we can find another factor because it wouldn't make an x cubed. At most, we could have 3 factors for an x cubed. If you had an x to the power of 4, at most you could have 4 factors. Now, one of the things that's really neat with this is that if you find one factor, so I'm going to use, just because we can still see it here, the idea that x minus 4 is a factor, and we found that. If you find one factor and you do synthetic division, you could have written a division statement right after that. That division statement would have looked like this. Well, this part would be the same, right? Your polynomial stays the same. You divided by x minus 4, so that's your divisor. Your quotient was x squared minus 2x minus 3. And so what we have here is our polynomial. Here's our divisor. Here's our quotient. We don't write anything for the remainder because the remainder was 0. And this is starting, if you find one factor, you can start to factor it. And when you start to factor it, you're going to get to a quadratic here. Do you know how to factor quadratics? Yes. So I'll rewrite the x minus 4, and I'm going to factor this. Well, it's going to have to be x and x. 3 and 1 to get a minus 2, need negative 3 and a plus 1. And that's the same as that. So it's giving us a sense for how is this going to look? How are we going to know how to factor this? If you can find one factor, then you can break it down and be able to solve the other ones.
Look at the numbers I just realized. Negative 3 times negative 4 is equal to 12.
Yeah, negative 3 times negative 4 is equal to 12. And so, in fact, some of the same strategy, you know when I factored this, one of the strategies I've been using all year is saying, look at your first one because that matches up with these two, right? Look at your last one because that will match up with these ones. And then we have to look at the outside and the inside, right? The opposite of multiplying, we also use that for factoring to come up with the middle. Something similar is going to happen with the big one. And what Peter just noticed here is that if we look at all of the last ones here, Do you notice that 1 times negative 3 times negative 4 matches up with our last one there? But when you have three things, you have a whole bunch of, like, there'd be arrows going everywhere here. So in the middle here, there's like a whole bunch of outsides and insides. So we're not going to learn a new acronym for yo. We could, but it gets complicated with all of the arrows. So to figure out these middle things and to figure out how they're going to work out, we need to find one factor first, right? Just like I did in this example in green here. If I knew x minus 4 was one factor, I could rewrite my division statement, and eventually I'll get down to a parabola or a quadratic equation, which you already know how to factor, and then you can factor it completely. Okay, we're not going to work on these right now. I'll just give you the questions 10a and 12. Remind me this afternoon's class to give you a little bit of time, or later this morning, give you a little bit of time on 12. I want to discuss something on that. I have a morning class, the second one's in the afternoon, but this is a weird year where they're both in the morning. The worst is when they schedule it to have 2 in a row.
Oh, jeez.
You have like 2.5 hours of 2 hours and 16 minutes of math in a row in the morning. It's just,
Must not be very productive.
well, you have to be the same amount of productive, but yeah, right? Normal person, their brain shuts off at what? 7 minutes into class?
Yeah.
Right? So then you have 2 hours and 9 minutes of wasted time.
Right, my brain only shuts down at 15 minutes, so you get an extra 3 minutes.
Oh, did I start a video again?